To start with number 9. The limit as x goes to 0, cotangent of 2x divided by the cosecant of x. I think I neglected to say, but it goes without saying, that the reason that we're going to do these rewriting these trig functions is because if I try to evaluate cotangent of 2x divided by the cosecant of x, and I just do substitution there, cotangent of, as x goes to 0, of 2x is going to go toward infinity. And the denominator, as x goes to 0, the cosecant of x, which is the reciprocal of the sine at 0, sine of 0 is 0, so that reciprocal again is going to be, this is going to be an infinity over an infinity indeterminate form. The limit as x goes to 0 then, I'm going to think of cotangent of 2x, the cosine of 2x over the sine of 2x, and then I'm going to write the cosecant of x as a reciprocal of the sine of x. I'm now going to change that to the limit as x goes to 0 of the cosine of 2x over the sine of 2x, rewriting this denominator 1 over the sine of x as the sine of x. Now I cannot cancel these because the arguments are not the same, but there is an identity. It says the sine of 2x is twice the sine x times cosine of x. So this becomes cosine of 2x twice sine x cosine of x. I still have that sine of x in the numerator. Now the sine of x cancels. And as x goes to 0, cosine of 2x goes to 1, just as cosine of x goes to 1. I have a 2 in the denominator, and again, we just said cosine of x as x goes to 0 is 1. So that answer is 1/2. Number 10, a little bit different problem. I'm going to assume that you might have tried a number of different things, manipulations. This numerator is 0, the denominator is 0. But what does work is I'm going to divide both the numerator and denominator by theta. Rewrite this as sine of theta over theta, then separate this denominator, theta over theta, plus tangent of theta. I think on second thought I'm going to right now rewrite that tangent of theta as the sine of theta over the cosine of theta, but remember I still had that theta there. This is going to be simplified to 1. I know as theta goes to 0, this goes to 1, as does this. So my numerator is 1, the denominator is 1 plus, and I just have to make sure that this is 1, and indeed as theta goes to 0, cosine of theta goes to 1. So my answer is 1/2. And I need to move that over just slightly for you for a moment. Okay, 2 more problems to go quickly. Number 11. The limit is theta goes to 0, tangent of 2 theta divided by theta, rewriting tangent of 2 theta as the sine of 2 theta over the cosine of 2 theta. I'm going to leave that theta there. And again, sine of 2 theta, I'm going to rewrite as twice sine of theta, cosine of theta. Now again, as theta goes to 0, this goes to 1. So I have 2 times 1, and we said a number of times, as theta goes to 0, this goes to 1, this will also go to 1. That answer is 2. And finally, number 12, one that somebody has already asked about, and now is the time to do this. We are actually going to be, this is using the limit definition of the derivative, as you recall. I hope you recognize it as that. And to find the derivative of the cosine of theta. The cosine of the sum of two angles is cosine of theta, cosine of h, minus the sine of theta, sine of h. Now I still have this cosine of theta to subtract. Let me get that in the view. I'm going to see that I have a common factor of the cosine of theta for these two terms, the first and the last. When I factor that out of the first term, I still have a cosine of h. When I factor it out of the last term, I have a 1. Now remember, this is all over h, but I'm going to separate it into two parts. Now I have the sine of theta, sine of h, and keep that over h as well. Okay. As theta goes, or h in this case, we're no longer talking about the h, or theta, we're talking about h. As h goes to 0, this goes to 0. So even though this goes to 1, this is 0. And as h goes to 0, this goes to 1. So minus the sine of theta times 1, or the opposite sine of theta. And that is the derivative of the cosine.